This is the 2013 Structure and Bonding paper. This is question 1C part 2. So, let's go. Elements M and X, they could be anything. Right? Don't let that put you off. Just read the whole question, and this is testing your ability to think a bit more in the abstract. Okay, so don't let that put you off. Elements M and X form a compound MX2. Atoms of element X have a higher electronegativity value than the atoms of element M. Therefore, bonds are polar. Depending on what elements M and X are, molecules of the compound formed will be polar or nonpolar. State the most likely shapes of the molecule if it is polar and then nonpolar. Well, to have a nonpolar element, you're going to need a linear shape. It is the only way it's going to work, because then you'd have X, M, X. X's would cancel each other out and make that nonpolar, because these individual bonds are polar. A polar shape is going to be bent. It can be either bent 3 regions or bent 4 regions. Justify your answer and draw diagrams of the possible molecules with dipoles labelled. You do not need to identify what elements M and X are. Alright, so justify your answer and draw diagrams. So let's do, well, I've already done linear up here, so let's just finish that off. Linear, we're going to have M, X, X, no dipole. And then we need to say, explain why we've chosen this. So the bonds X, M are polar, and therefore they need to be, the molecule needs to be symmetrical for those bonds to cancel out. I'll just move straight on to bent 3 regions and bent 4 regions. So bent 3 regions is going to look like this. You're going to have your M, and then your X, and then your X, and then you're going to have one lone pair up the top like that, pushing it down. So let's just make sure they get it. Non-polar, polar down here. The bonds are polar, and so the shape has to be non-symmetrical. So the bonds don't cancel each other out. Here a lone pair provides asymmetry. And so this molecule is polar. Bent 4 regions. And then C above. Okay. Oh, I needed, now that I see the marking schedule, needed to put the dipoles in. So here we are given the fact that X has a higher electronegativity value, which means that this is going to be negative and this is going to be positive. And then the same here.